The election data set, which I also have up here, lists the heights in centimeters of each president and opponent in an election. We want to use the opponent as the response variable and find the least squares line of best fit. So I have that data down here. We want these two. So copy and paste. So we have our predicted values, our residuals. The box plot looks close to pretty much being normal. There's a little bit of variation up here. It's kind of questionable, but it looks pretty normal, so that's good at least. The line of best fit. We have our slope of 0.0975 and a y-intercept of 161.8385. We have an r-squared value of 1.28 though. Ooh. Let's find out what that means by inserting a scatter plot here. And we could see exactly why that is such a low number. Look how far out these points are. And if I put in the not in that particular screen, but if I put the trend line in here, just so we could see what it looks like, you could see that line does not really describe all those data points that nicely, which is why it has such a low r-squared value. Despite the fact that this looks like a little variation from the normality assumption, but it does not do a good job of describing it. But anywho, the line of best fit would be y hat is equal to 161.8385 plus 0.00 0.0975. Had too many zeros there. Times x. For this, y is the opponent's height. And x is the president height. Again, both of these are in centimeters. We first want 90% confidence interval on the slope. So for that, we need to go to this Model Inference tab. That 90% confidence, we need to change this value here to 90. And we get the predicted slope of 0.0975. That's now going to add and subtract 0.4398. So from this, we have our lower bound. I'm not going to write it out just so I have enough room to actually type this last part, but we have a lower bound of negative 0.3423 and an upper bound of 0.5372. So to write this out in words, we are 90% confident that the average change in opponent's height for each additional 1 centimeter change in president's height, which is the interpretation of our slope in this case, is between negative 0.3423, whoopsie daisy, negative 0.3423, and 0.5372. And I forgot to put a dash between 1 and centimeter. Okay, that's for that one. Then the last one, we want to predict the height of the opponent if the height of the president was 180 centimeters and form the 95% prediction interval around that height. So we're going to prediction inference. We're going to put the height of the president here of 180. This has to be an x value. And we're going to change this level of confidence to be 95. And I need to expand this out so we can see these numbers. Excuse me, not that one. We want this one to be 95. I changed the wrong one. This is going to give us then, for our prediction interval, a value of 179.3802 would be the predicted value. But then the prediction interval I have here on the bottom of being between 169.1734 and 189.5869. So the predicted height, I'm just going to type that one out too. Again, just to attempt to make sure I have enough room here. As you can imagine, it's going to be a long-worded one. There we go. So the predicted height for a tree. Excuse me. The predicted height for the opponent. The predicted height for the opponent where the president is 180 centimeters tall is 179.3802 centimeters. Okay, and from that we are 90% confident that the average height of the opponent, with the president being 180 centimeters tall, is between 179.3802 centimeters and 189.5869 centimeters. Thank you.